Okay, good morning, everyone.
Good morning.
Did you have your Wheaties this morning? Good morning, everyone.
Good morning.
Very good. Okay, we're here because we're all learning this. So we have a lot of teachers here, and then you have myself, that I'm going to be the guinea pig. You know in science who the guinea pig is? Is the experimental creature, isn't it? That's what I am today. And we know that research says that in order for you to learn, we have to have engagement norms. And engagement is, how do we keep you learning and thinking in this class? So what we're going to try to do today, we're going to ask you to track with me and read with me. There's some words in science that are very, very difficult, so I'm going to pre-read them, and then you're going to read them. So I expect you to really read, because in science it's very important that we read, so we can read it afterwards, isn't it? And then the next one is gesture with me. Can you read that, please? Gesture with me. Sometimes I'm going to ask you to make the letter T. Can you make the letter T, please? Can we all make the letter T? I'm waiting for 3 of you to help me make the letter T. Can we all make the letter T, please? Thank you, thank you, thank you, thank you. The reason we're doing this is not because we want you to feel ashamed or embarrassed, but we really want you to learn this information. And research says that if we use hand gestures, we will remember it better. If we don't, then it's very difficult for the brain to try to remember and make sense of what this means. So can we all make the letter T, please? Very nice. The next thing that I'm going to do is I'm going to ask you to pair share. Pair share means that you're just going to talk to a partner, because research says that unless you are processing the information you're thinking about, you're talking to somebody else, it's more difficult for you to remember. So you have to really think about this. So I need to give you a partner. So you're going to be A, and you're going to be B, and you're going to be A, so you three are going to be talking. So sometimes I'm going to say, A talk to B, and then I want you to do the talking. And then B talk to A, and then you do the talking. And next time I say A, then you do the talking. Okay? So A, B, A. So you're going to be A, A. You're going to be A, B, and you're going to be A, B. Can you work with... Can you two work today just for a little bit? A and B? And how about you two? You're going to be A, B, and then you're going to be A, B, A. So I guess you can probably talk to them, and then you can talk to each other. At the count of 3, can you please show me if you're the A partner, please? A partner? The B partner. Very nice. So I'm going to give you lots of time to talk to each other, but then I'm going to say 1, 2, and then I want you to say eyes on you. 1, 2. And that means that it's my turn to talk. So you have lots of time to talk, but then I'm going to have my turn to talk. And that's what we call attention signal. I also have very high-tech whiteboards here. These are extremely high-tech, so handle them with care here. And inside your whiteboards, you have a very high-tech eraser. And this is, please take it out like this. And then you write on the whiteboard. And right now, this is what I want you to do so we can practice. I want you to write down the first letter of your name, or the first initial of your name. That looks like this. Make it nice and big so I can see it, please. Okay, and I'm going to say, wait until I give you my signal. I'm going to say, show whiteboards, please. And when I say show whiteboards, I want you to put them right here, please. Thank you. And if I walk around, I want you to walk around with your whiteboards so I can see them. Very nice. And sometimes I'm going to ask you, please show the whiteboards to your teachers in the back. So I want you to show the whiteboards to them, please. Very nice. And not until I tell you to erase your whiteboard, then you're going to take the high-tech eraser and erase your whiteboard. It is high-tech. You might not think so, but it is. Yes. You know how long it took for a person to figure out how to do that? A long time. Okay, so complete sentences, what that means is I'm going to give you a sentence frame, and I'm going to ask you to say, it is a chemical reaction because. And I want you to use the vocabulary of science today, because that's the only way you will remember it. So let's try some pair share right now. I want you to turn to your partner and tell your partner, why do we have engagement norms? Why is it important to have engagement norms? And I want A to go first. So go ahead and do that, please. Go ahead and switch. That means that now I want B to talk. So switch.
Remember what he
1, 2. 1, 2. Let's try it one more time. 1, 2. Okay, so it's my turn. So my question, why do we use engagement norms? Anna, and when you answer, I need you to say, we use the engagement norms because? Who's Ana Garcia?
We use the engagement norms so we could understand better.
Yeah, we can actually learn more. We're not doing this because we want you to have a terrible day today. We're just doing it because we want you to learn quite a bit today. Okay, one more person. Alba, who's Alba?
She's not here.
She's not here. Jose, why do we use the engagement norms?
I'm using engagement norms to pretty much rules that things we have to follow, so they help them learn better.
Oh, it's going to help us learn better. So we're going to really try to engage you today. The only thing that we have is we have a lesson that looks like this. Make sure that you have a lesson that looks like this. And I also need you to have a pen or a pencil. So right now, because we are not going to have time to go back and get pens or pencils. Show me your pencils, please. I'm waiting for 3 of you to show me your pencils. So let's try it one more time. Show me your pencils, please. Thank you, thank you, thank you. Very nice. Okay, and then I'm going to be doing a lot of checking for understanding, and you know what that means. That means that I'm going to be pulling out your name, and then I need you to answer your questions. Or I need you to answer my questions. But there's something that I want to explain to you. When I ask you to lift the whiteboards, and let's suppose somebody else has another answer, in this class, you can change your answer as long as you can justify it. We're trying to learn something new, and sometimes it's hard. So change your answer if you want. And another thing, if I see too many of you with the incorrect answer, all it's telling me I have to reteach. So the reason I need you to use whiteboards is because I want you to learn the information, and it's guiding me. What do I do? Am I confusing everyone, or is this clear to everyone? Isn't it? So that's the reason we're going to check all the time. Okay, so let's move on, please, and let's go to the lesson. And that's the beginning of the lesson. And there's one word here. Describe. Can we read it, please? Describe. And describe just means to tell in detail. When your teacher is trying to describe what a science experiment is, your teacher is trying to tell you in detail what a science experiment is going to be like. So describe means to give details. So when I say describe, you say give details, and when I say give details, you say describe. Describe? Give details? Describe. That's what it means. I want you to turn to your partner and tell your partner what is the meaning of describe, but maybe you want to even give me a sentence with describe. And B, go first. Go ahead and do that, please. Switch, please. Now B is your turn. A is your turn.
That's what I said.
1, 2. Wendy, what is the meaning of describe? And when you answer, you can say describe, or you can give me a sentence.
To describe means to give better details.
Good to give me a high five. Very nice, from a distance here. One more person. Antiana? Is that Auntie Annie? That's a beautiful name.
Describing details.
To give details. Do I have a volunteer who wants to even give me a sentence? A sentence with describe? Please don't all volunteer at the same time. That's okay. Let's take a look at here. This is a phrase, and we say it together. We read it, conservation of matter. Can you read that, please? Conservation of matter. And I want you to go ahead and underline that on your page, please. So this is what we will do today. Let's read it together, please. Let's read it together. We will describe the law of conservation of matter. So I want you to read to your partner, not tell to your partner, but read to your partner what we're going to do today, please. And B, go first. Go ahead and switch. Go ahead and switch. Okay, 1, 2. Okay, Elizabeth, what are we going to do today? Elizabeth? Uh-huh. Of conservation of matter. And then one more person, Jasmine, what are we going to do? Who's Jasmine? Is not here? All right. Angel? Is that Angel or Angel?
We will describe the conservation of matter.
Okay, the law of conservation of matter. But before we do that, I have an experiment here that we're going to do here. You see, I have baking soda. Do you know what this is? Have you seen it in your house? Usually your mom will put it in the refrigerator, isn't it? And this is vinegar. You know, when you have a salad or something, we like to put this in with oil, and then we put it in there. How about these are called chemicals? These are 2 chemicals. But today I'm going to combine them. That means that I'm going to put them together. So when I say combine, you say put them together. Let's start this. Combine means to put them together. Let's go like this. Combine means to put them together. So I'm going to put them together to see what happens. And inside here is going to be the baking powder. And in here we have the vinegar. Should I try it? But before I know that you have to put in your goggles here. Oops. If I can still see. Okay, so I'm going to combine them. In here I have the baking powder. So something is happening here, isn't it? We combine something, but this in here we have carbon dioxide that is a gas. But in here we did not have carbon dioxide. We had actually baking soda and then we had vinegar. I want you to talk to your partner and tell your partner, what do you think is happening here? Go ahead and go first. Go ahead and do that, please.
When it got like, when it reacted,
Now go ahead and switch, please. One, two. Very nice. All right. So what do you think? Remember, there's no right or wrong answer. We're kind of looking at it. What we know for sure is that something happened. So tell me what you think happened. Is that brim?
That's not funny. Evaporation?
Is it evaporation? I mean, water is, when we talk about the phases of matter, sometimes we talk about evaporation, and that what means is that water is going to turn into gas. So that's what might be what's happening. In this case, what we have is we have two chemicals together that somehow, when they were combined, they created something else. Or actually, I'm sorry, we produced something else. And today, you're going to see that we produce something else. The atoms in here will remain the same. We're not going to change them. They're going to remain the same. And today, we're going to call that the law of conservation of matter. What do we call that? We call that the law of conservation of matter. So let's turn the page, please, here. This is going to be hard to read this. Okay, so let's take a look at what is a chemical reaction. So let's take a look at a chemical reaction. There's a word here that I want you to take a look at it, and it says reorganize. Can we read this, please? Reorganize. And if you look down here, reorganize means to rearrange. So if we take a look at a chemical reaction, let's read the chemical reaction, please. A chemical reaction, remember what I told you? I need you to read science. So I'm going to have to hear all of you reading science, because then you'll be able to read your book and all of that. Can we try it one more time? Let's try it. Let's read it. A chemical reaction is a process in which atoms are reorganized into different combinations of molecules. Let's take a look at what that means. Take a look at this. These are reactants. These are the starting molecules. We started out with hydrogen here and oxygen. And then they were put together. Let's go like this. We put them together. We combine them. Let's go like this. We combine them. And when we combine them, at the end, the products, they're no longer what we started out with. But if you notice the atoms, we have hydrogen here, we have oxygen here, and help me, what do we have at the end? We have hydrogen atoms, and then we have oxygen atoms. But these molecules are very different than the ones that we have at the end. It's very important to know that in a chemical reaction, the atoms are reorganized, and then they make different combinations of molecules. But that's not what we're learning today. We're learning the law of conservation of matter. So let's take a look at what that means. And conserve, can you read this word, please? 1, 2, 3. Conserve. And if you take a look at this one, it has a little 4. And if you go down here, Conserve means that it doesn't change. Conserve, when I say conserve, you say doesn't change. When I say doesn't change, you say conserve. So let's read this together, please. The law of conservation states that in a chemical reaction, the number of atoms is conserved no matter how they are arranged. So what does that mean? Look at this. Can you help me count how many hydrogens I have? 1, 2, 3, 4. And what do I have here? How many oxygens do I have? 1, 2. And then how many oxygens do I have here? 1, 2. And how many hydrogens? 1, 2, 3, 4. It's almost like your algebra class whenever you're looking at equation, isn't it? It says that we have 4 hydrogens and then 2 oxygens and then 4 hydrogens and 2 oxygens. So what I want you to do here, I want you to tell your partner, what is the law of conservation of matter? And then maybe you can say it in your own words. What is the law of conservation of matter? And see if you can say it in your words. And I want you to start. The law of conservation of matter is, so go ahead and talk to your partner, and B, go first. Go ahead and do that, please. And I don't want you to read it back to me, please. But try to put it in your own words.
The law of conservation of matter is that you mix 2 things, it's going to come out that. You might like to
Okay. 1, 2. 1, 2. Okay, I've heard some of you telling me you're going to mix these 2 things. You know, today in this class, instead of calling them things, because when you tell me you're going to mix 2 things, I do not know what you're talking about. So today we're going to say we're going to mix 2 molecules. 2 molecules, because these are molecules, and that's what we're mixing, isn't it? So we're mixing them. We can call them things, but in science, we would like to call them the way they are. So if I start here, and if I take a look at the reactants here, let's take a look at what the reactants are. Let's read it. Let's read that. In a chemical reaction, reactants are the starting molecules. Those means those are these molecules here, but take a look at what is the products. Let's read it. In a chemical reaction, products are the resulting molecules. And the resulting, all that means is the ending ones. So I have a question for you. I want you to go down on your lesson. And at the very bottom, I have one thing that is called CFU, checking for understanding. Can we read the first checking for understanding question, please? Which of the following are the reactants in the chemical reaction below? Okay, if I have this chemical reaction here, and I have this chemical reaction that says, this is what's going to be combined, and at the end we're going to have this. So which are the reactants? Is it going to be A? Is it going to be B? Or is it going to be C? On your whiteboard, I want you to tell me which one is it, and then I want you to talk to your partner and tell your partner the reactants are because. So go ahead and do that, please.
Because our you see the 2 for H, so it's pretty much hydrogen is 4, then you call the parentheses, it's pretty much like normal math, 2 times 8,
That's what I said.
Show whiteboards, please. Show whiteboards to your teachers, please. Show them back to me, please. Show them to your teachers, please. Show them back to me. Interesting. All right, let's take a look at this one. I see that, let me hear at least why they have that. It's very interesting. So let me, okay, I'm going to give you some other directions. You can put 2 letters if you want. I see that you usually put in 1 letter. So let's read it one more time. Let's take a look at what the reactants are. Let's read it here, please. Let's read that. 1, 2, 3. In a chemical reaction, reactants are the starting molecules. So if I take a look at here, what are the reactants? Let's read that. 2 molecules of H2 plus oxygen is going to give you the products, which is 2 molecules of water. So this is the reaction that I'm talking about today. We have 1 molecule of hydrogen, and we have 1 molecule of chlorine, and then that's going to give you 2 molecules of hydrogen chloride. So I want you to take a look at the question, and let's read the question. Let's read it together, please. 1, 2, 3. Which of the following are the reactants in the chemical reaction below? So if you were to choose 2 letters, which ones would you use? Go ahead and talk to your partner and be ready to tell me, please. And talk to your partner and go first. Oh, you thought it was only one answer? Yeah, please put it on your whiteboard so I want to see it. Okay, at the count of 3, show me your answers, please. Show the answers to your teachers. Show the answer to your teachers here, please. Very nice. Put down. Now I'm going to ask you, and then when you answer, please do not raise until I see your answers. Show me your answers one more time, please. Very nice. So now I want you to tell me, why do you have on your whiteboard, and why is that? And I want you to say the reactants are Alba,
She's right here.
she doesn't know what she's missing. David? Who's David? Yes. Okay, the question is, on your whiteboard, what do you have on your whiteboard? And what are those called? The reactants are?
The reactants are A and B.
And why is that? I'm going to give you 2 choices. Are those the chemicals or the molecules at the beginning of the reaction, or are those at the end of the reaction?
Beginning.
The beginning, so that's why those are called the reactants. Okay, one more person. What do you have on your whiteboard? And I want you to say, these are the reactants because Beatriz Rojas? How many people are absent today? Don't they know that they come to school every day?
3.
Martha?
The reactants are A and B because they're the molecules before the
At the beginning of the reaction. At the beginning of the reaction. That's the starting molecules. That's the starting molecules. Okay, so I have another question for you. Let's read the second question, please. And let's read that together. Let's go. Which of the following are the products in the chemical reaction below? And be ready to tell me why that is. And go ahead and talk to your partner. And B, go first. Go ahead and put it on your whiteboard, please.
Can we delete it?
Go ahead and write the whiteboard. I want you to answer question number 2. Which are the products? Is it A, B, or C? Now show me your whiteboards before I ask you to show them to me, please. Not yet. At the count of 3, show your whiteboards, please. Show the answers to your teachers, please, in the back. Show them back to me, please. Put them down. Now I want you to tell me, what do you have on your whiteboard and why is that? Omar? Who's Omar?
He's not here.
Ana Garcia?
Right here.
Can you say the products are, or the product is?
The product is C
And why is that?
because it's the answer for the both of the reacting.
Is it the answer or is it the ending?
The product.
What are those?
Huh? Resulting. of-
Okay, and resulting, what does that mean? Does that mean at the beginning or at the end?
At the end.
At the end, that's what that means. What do you have on your whiteboard and why is that? How about you in the middle? You really look like you really want to answer this. That's fine, you were correct. What do you have on your whiteboard and why is that?
Because that's the product, that's what
Which one are the products? Which one is the product?
C, the last one.
And why is that?
Because that's what reacted to get that.
Okay, and that's what do we call those? Are those the starting ones or the resulting? Which ones are those? The result, very nice. Okay, go ahead and erase your whiteboards, please. Okay, but we are really looking at, let's read that together, please. 1, 2, 3. The law of conservation of matter states that in a chemical reaction, the number of atoms is conserved no matter how they are arranged. So if I look at here, I have 4 hydrogen at the beginning, starting, and then I have 4 hydrogen resulting. I have 2 oxygen and 2 oxygen. They are rearranged, but they do not change. They remain, actually the atoms are the same. They are, no matter how they are arranged. They're not going to make more. This cannot be 4 and 5. This cannot be 2 and 7. They're going to be exactly the same. So I have a question for you here. Let's take a look at the checking for understanding question. And let's read question number 3. And let's look at it. How many atoms of hydrogen in the reactants below? So these are the reactants below. So how many atoms of hydrogen do we have? Go ahead and write it on your whiteboard. Do we have A or do we have B? Go ahead and talk to your partner and B, go first.
What is 34? What's 34?
And instead of putting A or B, I want you to put the number that you think it is. Go ahead and write it nice and big, and A, explain your answer to B. And show me your whiteboard, please. Show the answers to your teachers, please, in the back. Show the answers to me, please. All together, how many do we have? We have 2. Very nice. Okay, so now put your boards down, please. And I'm going to go to the next page here. And I want you to take a look at this one. I'm the only one who has this. Let's take a look at this one. We start out with these molecules here, and we call this titanium chloride. It's over here. And then we have magnesium over here. Yields, that mean that the products is going to give us titanium, and it's going to give us magnesium chloride. But it's a chemical reaction, so we know that it's going to rearrange. And at the end, we're going to have this, 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 and this. I want you to talk to your partner, and this is the last question that I have. How is this reaction represents the law of conservation of matter? What is this representing? And representing means is showing. So when I say represent, you say shows, and when I say shows, you say represents. Represents. Shows. Represents. So why is this, when you look at it, representing the law of conservation of matter? Go ahead and talk to your partner, please. And A, go first. And it's that it is representing the law of conservation of matter because?
No, I'm the other age. I'm the other age. So see up there? You know that's for chlorine, 290. That's on both sides.
Numbers.
So you see,
Oh, yeah.
it's the same number of atoms.
Okay, 1, 2. Okay, so now I'm going to ask you, why is this equation, why is this chemical reaction representing the law of conservation of matter? I want you to say it is representing the law of conservation of matter because, and that's going to be Hector Martinez. Who's Hector Martinez? Who's Hector Martinez? Can you please show yourself so I can see? Good. You're the lucky person. Why is this representing the law of conservation of matter? Can you say it is representing the law of conservation of matter because? Can you say it is representing the law of conservation of matter because? Okay, it's combining. We know it's combining, but what's so important about the law of conservation of matter? Okay, how many atoms of chlorine do I have on the reactants? And how many atoms do we have in the products? How many atoms of chlorine do I have in the products? 4. So how many, did I make up any chlorine on this? Was anything made up? No. That's what the law of conservation of matter is. One more person. Is that Jasmine? Or Cedric? Cedric, lucky person. Can you say it represents the law of conservation of matter because?
It represents the law of conservation because it has like the same amount of chlorines, Mgs, or magnesium, and titanium on both sides.
Okay, give me a high five. Very nice, very nice. Then one more person, please. Joseph. Who's Joseph Jones? Joseph, it represents the law of conservation of matter because?
amount of like molecules on both sides.
Okay? The same atoms on both sides. That is the reason why. Give me a high five. Do you have any volunteers to tell me why is that the law of conservation of matter? Any volunteers? You look at you really want to tell me. So can you say it represents the law? You, yeah. What? Yes. It represents the law of conservation of matter because?
It has the same number of
No, it represents the law of conservation of
It
matter.
represents the law of conservation of matter because there's the same atoms on both sides.
On both sides. And that's, let's all say which ones they are. We have 4 chlorine, and then over here we have 1 titanium, and we have 2 magnesium, and nothing was created. All we did was rearrange them. Let's go like this. Rearrange them, but everything remained the same. Thank you very much. Go ahead and please put your whiteboards, put the marker inside your whiteboard, put the high-tech eraser inside your whiteboard.